Welcome to today's session on Poisson regression. How to build Poisson regression model using R programming. So the Poisson regression equation is log of y is equal to a plus b1 x1 plus b2 x2 plus etc bn xn etc. Okay. So here we are going to take a data set warp breaks. So this is a data set available in R. So this data set consists of a response variable called as breaks and predictor variable called as type and tension. Okay, so this is about the number of breaks that has to be applied for wool weaving. Okay, so the type of wool to be weaved and the tension to be given and the number of breaks to be applied for the wool weaving is there in this data set warp breaks. Okay, so we are going to explore this data set first. So let me open the data set. So the data set has three columns: breaks, wool and tension. So the number of breaks to be applied and the wool type and the tension type is shown in the warp breaks data set. Okay, so the type of wool is A or B. So there are only two types of wool, A or B, and the type of tension is low, medium or high, represented as L, M and H. Okay, so let me first build a Poisson regression model using the function GLM. So GLM is a function which is used to build Poisson regression model in our programming. So here we are taking the formula is equal to breaks, which is the response variable, against the predictor variable combination of wool type and tension. Okay, so the data is warp breaks and the family is given as Poisson. So it means that we are going to apply Poisson regression on the warp breaks data set, considering the response variable as breaks and the predictor variable as the wool and the tension. So the result will be stored in model 4. Okay, so let me execute this syntax. So now the result is there in model 4. So let me print the summary of this model 4. So what do we understand from this summary? So in this summary, so we can see the three variables, that is wool B, tension M and tension H, that is high tension and medium tension, and the wool type is B. Okay, so for these values the p value is less than 0.05. Okay, so based on the p value only we can see whether the predictor variable has any impact on the response variable. The response variable is nothing but the breaks, and the predictor variable is nothing but the wool type and the tension. Okay, so we can see from wool B the value is 6.49 e to the power of minus 0.5, so it is less than 0.05. So for tension medium, the p value is 9.73 into e to the power of minus 0.8, which is less than 0.05, and for tension H the value is 5.21 e to the power of minus 16, which is also less than 0.05. So from this what we can understand is that the wool type B having the tension type M and H have impact on the count of breaks. Okay, so this is what we can study from this model. Okay, so hope it is clear how do we understand a Poisson regression using R programming, how to build a model using the GLM function in R programming, and how to understand the summary of the model and how to understand the data behind the model in the data behind. Okay, so whether the response variable predictor variable has impact on the response variable or not, or which predictor variable has impact on the response variable. Okay, so this is about the Poisson regression. So let us also see about non-linear least square regression. So for this the equation is A equal to b1 star x to the power of 2 plus b2. Okay, so we are taking two variables x and y. So x is having some 10 values and y is also having some 10 float values. So I'm running x and y, and I'm plotting these values of x and y in a scatter plot. Okay, so we can zoom this scatter plot and see here the points of x and y are plotted in a scatter plot, x in the x-axis and y in the y-axis. Okay, so now I'm going to build for non-linear least square regression using the function NLS. NLS is the function which is used for non-linear least square regression. So this is drawn for the model y against b1 star x to the power of 2 plus b2. So we are starting the value of b1 and b2 as 3. Okay, so we are going to see what is the expected value of b1 and b2 after building this model. Okay, so let me run this and see. So the model has the values of the expected value of b1 and b2. So now I'm storing a new data type called as new, which is a data frame whose value is the x value starting from the minimum value to maximum value. So this new data type is created. So, and I'm drawing a line using this new data type and also using the prediction of the model for this new data type. Okay, so I have drawn the line. See, now the curve is not a, it is not a straight line, it is a curve. So if it is a linear regression, it will be a straight line. Since it is a non-linear regression, it is a curve. So the data points fit in a curve, not in a straight line. Okay, so we have fitted the data for the values of x starting from the minimum to maximum, and using the function lines the curve is drawn. Okay, so let me understand what is there in the model. So I am finding the residual value of the model. So this res1 is 1.08 and res2 is nothing but the confidence interval of the model, that is the confidence interval for the values b1 and b2 of the equation. So already we have set initial value as b1 is equal to 1 and b2 equal to 3. So now let me understand the confidence interval of this b1 and b2 by printing the res2. Res2 is nothing but the confidence interval. See here we can see for 2.5% of confidence interval, B1 takes the value 1.1377 etc. And for 97.5% of confidence interval, B1 takes the value 1.2531 etc. And for B2, for 2.5% confidence interval, it is 1.49 so on. And for B2, 97.5% of confidence interval, it is 2.4964 etc. Okay, so from this what we can conclude is, we can conclude that the value of B1 is more or less close to 1, taking both the intervals, that is for 2.5% and 97.5%, it is close to 1, but the value of B2 is close to 2 and it is not close to 3 as we have set in the initial model. Okay, so the model has to be refined again by setting the value of B2 to 2. Okay, so then we'll be getting better results for the plot. So the line will be more smooth. So that is what we understand from this. So we have understood how to build a model for non-linear least square regression. For that we have considered a sample equation a equal to b1 star x to the power of 2 plus b2, and we have taken two values x and y and we have plotted that, and we have built a model using the function NLS by setting b1 equal to 1 and b2 equal to 3. By predicting the model, using the model we can draw the curve for which fits the data, and we can see it is non-linear. And seeing at the confidence interval of the model, the value of b1 is nearing 1 and value of b2 is nearing 2 and not 3. So this is what we have understood. So today we have seen about Poisson regression and we have seen about non-linear least square regression. Hope it was useful. Thanks for your patience listening.